see Miss Grindle. Miss Grindle, you ain't sick, are you?
Yeah, I'm sick again. You can thank my son.
Oh, okay. I'm sorry. I knew you were quiet. So, all right. Solving linear inequalities. Well, I just pulled that up just to make sure y'all understood what the section was. This is your last section before your test on 6.1 through 6.5. We will have a 6.6 test by itself, and I'm going to hand y'all out. I'm going to give y'all some. Handouts before we meet for 6.6, but that's after the test, 6.1 through 6.5. So let's go to our handy dandy whiteboard and let's talk about inequalities. Now, up until now, y'all done, I think it was 6.2, and we taught you how to solve equations. And we went through and we did combining like terms. We did distributive law. And we did clearing fractions and decimals. Everybody with me? All I need is one yes, because one yes means that I did cover it. We did go over all this, right?
Yep.
Okay. So let's do an example right quick. 2 times x plus 3 is equal to 12. And we distributed, and we got 2x plus 6 is equal to 12. Subtract 6. 2x is equal to 6, and x is equal to 3. And we talked about, to check the answer, you could take that 3 and back substitute into 3 plus 3 is 6. 6 times 2 is 12. 12 is equal to 12, and it would check. Now, let me ask you a question. Is there any other number besides 3 that will work in this equation? Yes or no? That means I want somebody to say yes or no back. You got a 50-50 shot.
No.
No, there is no other number in our universe that will give us 12. Does everybody understand that? And that's why this is called a solution. Now, in 6.5, we're not doing equalities, we're doing inequalities. Okay, inequalities. And when you solve an inequality, you don't have a solution. You have a solution what?
That varies.
A solution set. And I think that's what you meant, Mr. Pack, by saying varies. In other words, you have a solution set. Now, the reason you have a solution set is because the 4 signs that you're using in inequalities are not this sign. The 4 signs that you're using are these signs. And those are the 4 inequalities. Now, did y'all notice anything while I wrote those down? I didn't call them anything, did I? I just said there's the 4 signs that you have. I despise when somebody calls this something, and this something, and this something, and this something, and they don't tell you what kind of context it is. I'm going to give you a word. Okay, which word am I thinking of? What's the meaning that I'm thinking of with that word?
It's either dessert or desert.
Well, I didn't ask you what it either was. I want to know which one I'm thinking of. You don't what? You don't know which one I'm thinking of. Why?
Because you didn't tell us.
No, because I'm not giving you context. Now, if I say vanilla with a cherry, you'll tell me what?
Ice cream. Dessert.
Dessert. If I say arid and dry, excuse me, what is arid and dry?
Desert.
Desert. Everybody with me? Context. Context. If I give you 4 symbols that are inequalities and I don't give you an X or a number, you can't tell me which one's which. X is less than 4 or 4 is greater than X. You have to have context. If I see you put a title with one of these and you do not have context, I don't understand how you did that. I don't understand how you could tell me what this means and what this means and what this means and what this means when you don't have anything on either side. That's like telling me that if I think of a word, oh, you're thinking of desert. How do you know what I'm thinking about? That word has 2 or 3 different meanings. You got to have context. Now, when you have these 4 signs, this is going to be written in red. Why is it going to be written in red? Because if you don't learn it and understand it, you're going to fail this part of the test. Those 2 guys, Mr. Allen, you are a winner. Actually, you can spell it. I think you can say it. You can actually use both words. I think, if I'm not mistaken, I think you can use both words. Somebody check my memory on that. But there are some words that are spelled the same way and they have 2 different meanings. I can't think of one right now except desert and dessert. But I agree with you. When I talk about a dessert, I use 2 S's. And when I think about the desert, I use 1 S, but I believe if you research it, I think you'll see that you can do either one. I'm not sure, but I'm pretty sure. At least that's the way I was taught when I was brought up K through 12. Some of you might have to research it. All right. So these 2 guys right here, these 2 guys, when you see these 2 guys in algebra, you're going to either use a open circle, you're either going to use parentheses, or you're either going to use a dashed line if you're graphing. All right. If you have these 2 guys, I wish I could draw those braces the right way. That one's pretty good. That one sucks. But I've always not been able to draw them. And that's after years and years of practice. I still suck at them. A closed circle, brackets, and a solid line, usually real thick. Okay. And remember that negative infinity and positive infinity, you can't touch, and they always get parentheses, always. Okay, now this is all in red because that's important. If you choose not to memorize this as of today, then you're going to be lost when I'm doing a problem and I choose brackets over parentheses, or I choose an open circle over a closed circle. So I want everybody to go ahead and look at that right now and make sure that you put that to memory, or at least make an index card. Also, there's three types of writing the answer in this section. One is the regular way. X is greater than 7. Okay, that's the regular way. You're used to drawing it that way. I mean, you're used to doing it that way. And that's called regular notation. Regular notation. And then there's another way where you take this way and you put braces around it. And you do X such that, and then you put that right here. And that's called set builder notation. And then there is the third way, called interval notation, when I say 7 to infinity. And that's called interval notation. Does all three notations mean any number greater than 7? Yes. That means numbers greater than 7. X is all numbers where X is greater than 7. And 7 to infinity, with 7 being inclusive, which tells us two new words. Inclusive or exclusive. Inclusive. Well, let's just think of the root word. I'm not an English teacher. But when you're included, what does that mean? That means I want y'all to say something.
You're a part of something.
Part of something, part of. That is a very good definition. And you're pretty much a winner because people include you. So we know what excluded means.
Not a part of.
Not a part of, meaning you suck. No, I'm just kidding. Not a part of. Like I'm a terrorist. Okay, I'm excluded. I'm outside the norm because I'm a veteran. Okay, so I'm not a part of the regular population. Okay, inclusive means these two guys. Exclusive means those two guys. Now, these are all the little things that you need to have on an index card before your test on 6.5, 6.1 through 6.5. But this is everything you need to know about 6.5. Why? Because you already know what to do as far as solve an equation, because you learned that in what? 6.2. So all the rules of solving equations apply in 6.5, except when you write the answer now, you've got to do it in respect to these three things right here. Now, I tell students the best thing to do when you get an answer or solution set, one, and I'm just going to write, this is just method, this isn't important, this is method. You're going to get your solution set. In other words, you're going to do the algebra and you're going to get a solution set. And then I tell students the first thing you do is graph it. Graph it where? Graph it on a number line. And then 3, decide whether you're going to write it in regular notation, set builder notation, or interval notation. Now, I tell my students to write it in all three. And that way, when you come up to a test, you're not scared of either one of them. Okay, so the first thing you're going to do with these problems is you're going to get a solution set using what? Using 6 point what? 2. Okay, you're going to do number 1 using 6.2. Then you're going to graph it on a number line using these properties. And then 3, you're going to decide, you're going to write it in regular notation, you're going to write it in set builder notation, and you're going to write it in interval notation. All right, so let's do 1. Oh, there's one other rule, and this is something I always tell students to try to do, and I told you this in 6.2, and I'm going to write it in pink, just, make it a little bit different. Always try to keep the variable what? Always try to keep the variable what?
By itself?
Positive.
Positive.
Always try to keep, I told y'all that in 6.2. Remember the little bucket? Remember the little bucket? Always try to keep the variable positive. Okay, I need somebody to tell me they remember the little bucket.
Yes.
Thank you. I'm sorry, Mr. Pack. I'm sorry I have to rely on you when Miss Grindle is sick. And Mr. Roberts, I appreciate you trying to fill in. The rest of y'all suck because y'all not communicating. And that's why you're going to have a corner closet office and nobody's going to talk to you because you don't interact with people.
I wouldn't use
Sorry.
the pink again.
What?
I couldn't even see it. I said I wouldn't use the pink again. It was really hard for me to see it.
Oh, I'm sorry.
It's okay.
Okay, I'm not going to use that pink again. Always try to keep the variable positive. Always. Here we go. Let's go with 2x plus 7 is greater than or equal to x minus 3. All right, I want you to do this problem. Miss Grindle, what's your question?
I need to hop off of this, Miss McClure. I cannot sit here much longer.
Okay, you need to leave?
Yes, sir.
Okay, you go ahead and watch the video. I'm going to load the video later. Have a good one and I hope you get better.
Thank you. Have a good evening. Bye.
Bye-bye. Okay, so 2x plus 7 is greater than x minus 3. And we're going to, what's the smallest bucket? Smallest bucket is the 1. And I'm going to take that across the river. And that becomes a negative 1x. So x plus 7 is greater than or equal to negative 3. And I'm going to take the 7 across the river. And x is greater than or equal to what? Negative 10. Now this is the regular notation. So I've already got one of my ways to write it down. Now I'm going to draw a number line. This arrowhead right here is called negative infinity. This arrowhead right here is called positive infinity. And you should have learned that from like the 2nd or 3rd grade on. Okay? 0 is in the middle. Negative 10 is down here. Positive 10 is up here. So I'm going to graph this sentence right here. So all numbers are greater than negative 10. Somebody tell me what they associate greater with or greater than. What do you associate that with? Do you associate it with positive or negative?
Positive.
So therefore, it's going to be to the right, correct?
Yes.
So I'm going to take my handy dandy orange highlighter, because I'm not going to use pink. Maybe the orange will show up a little bit better, or your orange marker. And I'm going to put a closed circle at -10. And I'm going to take my handy dandy ruler, and I'm going to shade all the numbers, including positive infinity. So let's check this. Is 0 greater than -10? Yes or no?
Yes.
Is 5 greater than -10? Yes.
Yes.
Is 10 greater than -10? Yes.
Yes.
Now, what about this guy right here? It means equal to, greater than or equal to. So that's why this is inclusive, because it means -10 is equal to -10, and -9 is greater than -10, and 0 is greater than -10, and 10 is greater than -10, and 1,000,000 is greater than -10. So this one's inclusive because of the closed circle and the equal sign. So now I'm going to write it in set builder notation, which is just this answer with some stuff around it. So I'm going to go ahead and write a brace and X such that, and then I'm going to just plug this in. X greater than or equal to -10. And that's called set builder notation. Okay, now, one question. Which way do we read?
Left to right.
We read from left to right. All of us read from left to right, unless we're from the Middle East, Masalama. Okay, most of us read from left to right. I once tell y'all that I had a student complain about me because I said Masalama. And my department head asked the person, said, what does Masalama mean? And they said, I don't know. So they complained about me saying Masalama, but they didn't even know what the hell it meant. Masalama, does anybody know what that means?
It doesn't mean anything.
It does. It means go in peace, walk in
Okay.
peace. It's what we were taught to say to people when we were over in Saudi Arabia. But all they heard is, unless you're from the Middle East, and they heard that, and they complained that I said something about the Middle East. Whatever. Okay, we read from left to right. So I want you to tell me where our eyes hit the orange first. Where does our eyes hit the orange first?
The -10.
Good job. And where does it end?
The end of the number line.
Which is?
So infinity.
Infinity. Okay. Bracket and parenthesis. And that is called interval notation. Now, nobody should ask me, why did I put a bracket here and why did I put a parenthesis here? Because you have this page before. Somebody tell me why I used a bracket.
Because it ends, and you use a parenthesis because it doesn't end. It keeps going.
Okay, right here. I used a bracket because brackets means what? Inclusive. Because of what? Let me use the highlighter. I use these brackets because they're inclusive because of what? The equal sign. That's why I'm telling you, you need to know this page before you start asking questions, because I include -10 because of that equal sign right there. Well, Hubert, what'd you do in set builder notation? Well, set builder notation, you've got the equal sign right there. Well, in the number line, I got the closed circle. Closed circle. All right, let's do another one. Who's got a question on that one? Now, is this what you need to do with every single problem? Yes. I suggest you do all of these three things right here. And that way, when you're asked to do a certain way, you already know it. So let's do a nerd. Uh, 5x minus 7 greater than 10x minus 3. All right, I want you to solve it. And then I want you to find the solution set. And then I want you to put it on the number line. And then I want you to give me set builder notation and interval notation. I'll give you a minute or two to do that. That means everybody should be working. Was there a shooting in Boulder, Colorado?
Yeah.
I didn't know that. I don't watch news anymore. I haven't watched news since November, so I don't know what's going on unless somebody posts something on Facebook.
It's not like you're missing out or anything.
I know, and all it does is get my blood pressure up. Give you another 30, 45 seconds. All right, which one's the smallest bucket?
5.
5x. I want to take it across the river. -7 is greater than 5x minus 3. Take the -3 across the river. -4 is greater than 5x. And x is less than -4/5. And that is regular notation. Oh my gosh. I got x on the right side of the seesaw. Oh my gosh. That's awful. That means Jody is on the right side of the seesaw. It's not going to work. Draw it. -infinity, positive infinity, 0, -4/5, positive 4/5. Open circle. Somebody tell me what numbers, when you see less than, and it also begins with L, what do you think of, left or right?
Left.
Left. Sorry, Mr. Pack. I'm sorry you have to answer everything. Okay, so set builder notation, you just have to write a big fancy brace and an X such that, and then take this and put it in. X is less than negative 4/5. There's your set builder notation. Okay, which way do we read?
Left to right.
And where does our eyeballs hit the yellow first?
At the negative infinity.
And where does it end? Where does our eyeballs end?
At the negative 4/5.
And a parentheses goes on 4/5. So there's your two answers in set builder notation and interval notation. Now, let me go ahead and tell you this, and that way it'll be on record. You don't have to keep the variable positive. But what happens is students forget to divide through by negative, and they forget to flip the inequality when you do divide through by negative. So I don't teach that method. I teach keep the variable positive. 99% of the time, you can keep the variable positive. When can you not? Well, I'm going to show you that problem, and we're going to do this problem in red. Two x plus 3 is greater than 9 and less than 12. Well, negative 2x. There we go. All right. This is the problem that you cannot avoid the negative variable. This is the only time that you have to worry about the negative. So I'm going to get rid of the 3 first. And what I do in the middle, I got to do here and here. And I added an equality over here. I added that equality just now. And that's going to be 6 is less than negative 2x is less than or equal to 12 minus 3 is what? 9. Everybody with me? Ms. Roberts, are you still with us? Because you've been kind of quiet.
Yes, I'm still with you.
Well, I need you to help me out because Mr. Pack, I'm really worried about Mr. Pack. He's going to strain himself. He's working too hard today.
He is.
Notice I'm not asking anybody else because y'all don't talk. So divide by negative 2, divide by negative 2, divide by negative 2. Now, when I divide an inequality by a negative, it's going to change this to a negative and change this to a negative, and you got to flip the inequalities. Okay, when you multiply or divide by a negative, you have to flip the inequalities. And this is the only time you will see me not keep the variable positive. That's the only time I even show y'all this rule. Because most of the time on a test, you either forget to do it or you don't do it correctly. What I mean, don't do it correctly. Well, you'll get -3 and -9/2, but you'll forget to flip the inequalities. Or you'll flip the inequalities and you'll say 9 divided by 2 is -4. You'll do something because there's 2 or 3 extra steps. 2 or 3 extra steps versus keeping the variable positive. And on a test, that might get you. So what I do is I tell students, when you're doing regular problems, keep the variable positive, unless you run into one like this. And how do you know the difference? Well, this one has the function in the what? In the middle. And I'm going to draw this is my regular notation. And draw my number line. This is negative infinity. This is positive infinity. Actually, these are all negatives, so I'm going to draw -9/2 is -4.5. So this is -3. And this is -4.5. This is -4. And this is -5. And we'll say this is -1 and 0. Okay, -2 is right in here, but I'm just not going to show it. All right, now -3 is right here, and -4.5 is right here. I'll take my handy dandy and then, of course, I do my set builder notation, x such that x is between -3 and -9/2. Okay, which way do we read? Left to right. So which number do you hit the yellow first at?
-4/2.
-9/2, or -4.5. And where do I end?
-3.
-3.
And that's your answers. Now this is the 1% of the time, and I doubt very seriously I'll put one on the test. If I do put one on the test, there'll be just one. And the only reason I'm putting it on the test is because you might see it on a standardized test. The rest of your 6.5 will be these questions. Now I'm going to show you one more with the remaining time we have so you can do the homework. And this one you have to read the directions. Find the integers. Somebody tell me what integers mean. What does the word
They're whole
integer?
numbers.
I'm sorry, say again?
They're whole numbers.
All right, I want everybody to write that down because you will be asked this on the test and standardized test. Now, when we do this, when we shade all the number line like this, this is including fractions and what? Decimals. Fractions and decimals are between the whole numbers. Okay? But when you're finding the integers, you have to remember to exclude the fractions and decimals. how do you do that? You do that because integers equals whole numbers. So how do you do that? Well, the directions will say find the integers, and you just go through and you do a problem. Here's a problem. We'll do 3x plus 5 is greater than or equal to 2x, and I'm going to plus 10. All right, there's my problem. The only difference in this one and the other ones is not in the problem, it's in the what? Directions. So you have to watch the directions. This is very important because you will miss a problem on the homework because you've done all the math right, but you didn't read the directions. So you solve it as normal. Where's my small bucket? And that bucket comes over here. Minus 5, take it across the river. X is greater than or equal to 5. And you write it in set builder notation. And you also do it in interval notation, but I'm going to hold off on the interval notation right quick because I'm going to draw it on the number line. One, 2, 3, 4, and so on. All right. Now, when you're given integers, what numbers are greater than 5? I want you to tell me what numbers are greater than 5.
6 to
6 and
infinity.
above.
6, 7, 8, and 5 because it's inclusive. And how do I say forever keep going with all the whole numbers? You put 3 little dots above infinity or above this arrowhead. 3 little dots. That's very important. And I'm going to take this highlighter that is highlighted integers right here for y'all. And we're going to highlight these dots on each number and those 3 dots right there because you're going to see them again here in just a second. So how do I write my interval notation? Well, where do we see yellow?
On the 5.
On the 5.
6, 7,
And that's a bracket. And then where do we see on the right? Infinity.
8. Yeah.
Infinity. It gets a parenthesis, but guess what? Up in the top right-hand corner, somewhere up here, you can do it as an exponent, or you can put it on top of the infinity. You can put it right here. You can put it right here. I like to put it on top of the infinity. 3 dots. Because this means all numbers from 5, all whole numbers, integers, from 5 to infinity. So that means 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No fractions, no decimals, because you don't have this. I'm sorry, what? Oh, I thought somebody said something. The shade is not in between the numbers. And the shade is not in between the numbers. You just have whole numbers. Because what's in between the numbers? Fractions and decimals. So when you see this word in your directions, you make sure you think in terms of what? Whole numbers. And you will see that on the test, and you will see it. And right here, if you want to, you could put 3 dots here and you could put 3 dots here. Anything with 3 dots means whole numbers. And I know I'm running out of time, but we're finished for today. But I just want to say a few things before we close out. Anything with whole numbers, I'm going to put those 3 dots up here too. Anything with whole numbers, you're going to use those 3 dots. Okay. And that's what we will do. Now, this is the end of 6.1 through 6.5. So that means Friday, we're probably going to be going over homework 6.1 through 6.5 and unit 2A test review. That's 6.1 through 6.5. So that's probably what we're going to be doing Friday, okay? Question, gripe, complaint. All right, y'all get out of here, work on 6.5, and I will see y'all Friday.
You have a good rest of your day.
Thank you.
You do the same, and y'all cheer up. Y'all kind of in a gloomy mood today. What's up with that? Yeah, there's people leaving, just getting the hell out. Y'all make me feel bad.